Hi, this is Dr. Green, and welcome to our review for Exam 3. So, in this exam, I'm going to have you do a bunch of forward transforms and a bunch of inverse transforms, and then a couple of complete differential equations, and then probably conceptual question. So you will want to keep your Laplace transform sheet handy here. So, and I've got mine right here, and I'll be drawing from it as we go along. So first of all, we want to do Laplace transform of 3t cubed plus 2e to the negative 3t minus 2 cosine 2t. So first of all, Laplace transform is linear, so we can break this up, take the transform of each piece, and then factor out the constants. So this will be 3 times Laplace transform of t cubed, and then plus 2 times Laplace transform of e to the negative 3t, and minus 2 Laplace transform of that cosine 2t. And now we'll go to our transform sheet. So transform of t cubed, that is t to the n, so that's n factorial over s to the n plus 1. So here this is going to be 3 times 3 factorial over s to the 4th, and then plus 2 Laplace transform of an exponential. E to the at is, let's see, exponential, this first one here is 1 over s minus a. So our a is negative 3. So this is going to be times 1 over s minus negative 3, so s plus 3, and minus 2 transform of cosine 2t, and that is right here, cosine of kt, s over s squared plus k squared. Our k is 2, so it's going to be times s over s squared plus 2 squared. Okay, and we don't need to simplify these, so that's done. Next up, we want Laplace transform of 5t cosine 3t. So first of all, we can bring the 5 out. So this will be 5 times Laplace transform of t times cosine 3t. And now this is transform of t times a function. That's the second differentiation rule, if I remember correctly. So first differentiation rule is when you're doing transform of a derivative. Second differentiation, you've got a power of t times a function, and you end up taking derivatives and sign changes equal to the power. So we've got t to the first, so it's going to be negative 1 and 1 derivative of our cap f of s, which is our Laplace transform of f of t. So this, remember, is Laplace transform of little f of t. So we've got 1 derivative, so we've got a 5 out in front, and then it's going to be negative 1 sign change and 1 derivative of the transform without the t, transform of cosine 3t. And then this again is s over s squared plus k squared. So this is asking us, let's put this negative sign with the 5. So negative 5 times the derivative with respect to s. And this will be s over s squared plus 3 squared, because k equals 3. So that 3 squared is 9. So let's go ahead and change that to a 9. And then we want to do a quotient rule here. So let's let the top be our f and the bottom be our g. And we've got a negative 5 out in front. And then we want to do f prime g minus f g prime over g squared. So derivative of the top is 1. Times the bottom, s squared plus 9, minus the top, which is s, times the derivative of the bottom, which is going to be 2s, and then over the bottom squared. So s squared plus 9 quantity squared. And we could do a little bit of simplifying here. It's s squared plus 9 minus 2s squared. So we actually could have our negative 5 out in front. And then this would be 9 minus s squared on top. And then s squared plus 9 quantity squared downstairs. But if you stop here, that's fine. We've taken the transform, so you don't have to simplify. That's going to be your time saver on the exam. Next up, we want to take the transform of a function multiplied by the unit step function. Okay, so if we go to our transform sheet, that is going to be our second translation theorem here. So your second shift or your second translation transform of f of t minus a, u of t minus a gives us a factor of e to the negative as, and then you do the transform of the unshifted function. Okay, so and this is what ours looks like here. We've got a well, almost. We've got a t on the outside, and then we've got a shift on the inside. So we've actually got two things going on here. Let's take care of the multiplication by t. So that's what we just did. That was up here. That was second differentiation. So do a negative derivative, and then the transform of what's left. So this will be, taking out the t, will be negative derivative with respect to s, Laplace transform of what's left without the t, which is e to the t minus 2 u of t minus 2. And now these shifts are both the same. So we had to do that because the t here was not shifted, but the e, the exponential, was. So now these shifts are the same. So now this is our f of t minus 2 times u of t minus 2. And now we use the second shift formula. Okay, so now we're going to use this one. So that Laplace transform is going to give e to the minus as times the transform of the unshifted function. So this is going to give us a negative derivative with respect to s. And then we do, we get a factor of e to the minus 2s, because a is equal to 2. And then Laplace transform of the unshifted function. So our shifted function is e to the t minus 2. So our f of t here then, the unshifted function, is just going to be e to the t. Alright, so transform of e to the t is 1 over s minus 1. So this is going to be negative derivative with respect to s. And then we've got an e to the minus 2s times transform of e to the t 1 over s minus 1. And then we could write this as, this will be negative derivative with respect to s, e to the minus 2s divided by s minus 1. And now this is going to be a quotient rule again. So we got a negative out in front, and then we're going to do our top here is our f, and the s minus 1, that's our g. So derivative of the top, e to the minus 2s, times the derivative of this inside function, negative 2, times the bottom, s minus 1, minus the top, e to the minus 2s, times the derivative of the bottom, which is just 1, and then divide by the bottom squared. So s minus 1 squared, close it up, and we could simplify, but again, I'm not having you simplify on the exam. So that's good enough. We've actually taken the transform. Notice we do have a common factor of e to the minus 2s that we could pull out. That could simplify things a little bit. Alright, and let's see here. Next up, we are doing transform of an integral. And it looks like this is a function of tau, and this is a function of t minus tau. So it looks like we're doing a transform of an f of tau times a g of t minus tau. So we're doing that integral from 0 to t d tau. So when we go to our transform sheet here, we've got our convolution theorem, and then we've got transform of an integral. So these are the two that involve integrals. So if you're just doing transform of an integral, you do the transform of the inside function divided by s. Okay, but that's not quite what we've got. We're doing transform of a convolution. We're doing this. Okay, it's an f of tau g of t minus tau. So the Laplace transform of f star g, which is this guy right here, so the Laplace transform of that is just transform of f times transform of g, not shifted. Okay, so that's what we're going to use. So this means our f of tau is sine of tau, so that means our f of t is going to equal sine t, and our g of t minus tau is e to the 4t minus tau, so that means our g of t is just going to be e to the 4t. And what we're really doing then is we are doing the Laplace transform of sine t convolution with e to the 4t. Okay, so now it looks like this. So the transform of that is just multiply the transforms of the individual functions. So this is going to be Laplace transform of sine t times Laplace transform of e to the 4t. And transform of sine t, that's one of our basic transforms here. So sine kt is k over s squared plus k squared. Our k is 1, so 1 over s squared plus 1 squared is 1, times transform e to the 4t, so that's 1 over s minus 4. Okay, and that's fine. Just leave it like that. We don't need to simplify. So that one's done. And in 5, we want to do transform of a periodic function. Okay, that's graphed here. So this function is 3 from 0 to 1, 2 from 1 to 2, and then 1 from 2 to 3. So, but transform of a periodic. So go to our transform sheet here, and periodics were towards the end of the chapter. There we go, transform of a periodic function. Why don't we go ahead and bring this over. Okay, so there's our transform of a periodic function. And we first need to decide what our period is, our cap t here. So this is going to repeat every 3 units here, okay? So that's our cap t. So cap t is equal to 3, and f of t plus 3 is equal to f of t. So it repeats every 3 units. So then this transform is going to be 1 over 1 minus e to the negative, this will be s times 3, so 3s. And then this will be integral from 0 to 3 e to the minus st times f of t dt. Okay, well, our f of t is either 3 or 2 or 1, you know, depending on what interval we're in. Okay, so let's go ahead and rewrite our piecewise function here. So our f of t is 3 if you are between 0 and 1, so 0 less than t, less than equal t less than 1. It's 2 if 1 is less than equal t is less than 2, or it's 1 if 2 is less than equal t is strictly less than 3. So we need to take this integral and break it up into three pieces. So this is going to be 1 over 1 minus e to the negative 3s. And then this will be integral from 0 to 1 of e to the negative st times our f of t. But if you're between 0 and 1, that's this case, our f of t is 3. So this will be times 3 dt plus integral from 1 to 2 of e to the negative st times our f of t. But if you're between 1 and 2, that's this case, f of t is 2, so times 2 dt plus integral from 2 to 3 of e to the minus st. And between 2 and 3 here, f of t is just 1. So this is a 1. So just times 1 dt, or just dt. So then we just have to evaluate these three integrals, which are not too bad here. So we got a 1 over 1 minus e to the negative 3s out in front. And then the 3 here, we can factor that out of the integral. Same with the 2 here. So we got a 3 out in front. Integral of e to the negative st is going to be e to the negative st. And then this is a t integral, so s is a constant, so negative s is a constant. So you're going to divide by negative s, or if you want, multiply out in front by negative 1 over s. And then that's all going to get evaluated from 0 to 1. And then plus, that 2 is out in front. And then this antiderivative is the same thing. So we've got a negative 1 over s. Actually here, this parenthesis would not go around the 3. Just go around the negative 1 over s. Okay, and then antiderivative here the same, negative 1 over, not 3, but 1 over s, e to the negative st, but then that one's evaluated from 1 to 2, and then plus, nothing to factor out here, so this will just be negative 1 over s, e to the negative st, and that guy's evaluated from 2 to 3. And so this will be out in front. We still got our 1 over 1 minus e to the negative 3s. And now this negative s, we can factor that out of the evaluation, put it with the 3. So this will be negative 3 over s. And now just plug the 1 and the 0 in for t just in this part, e to the negative st. So e to the negative s times 1 would be e to the negative s minus, plug in 0 for t, e to the 0 is 1. Take this negative 1 over s and bring it out with the 2, so it would be minus 2 over s. And now just plug into e to the negative st, so plug 2 in for t, so e to the minus 2s, minus, plug 1 in for t, e to the minus s, and then again, take and factor the negative 1 over s out of the evaluation, minus 1 over s, so now we're just plugging into e to the negative st, plug in 3 for t, so e to the minus 3s, minus, plug in 2 for t, e to the minus 2s. And that does it. So that one's evaluated. Not simplified, but evaluated. So those are the forward transforms. So I did a variety on the practice exam here, and I'm just going to do a variety on the exam. I will mention that you do get to omit one of the transform questions, okay? So you won't have to know how to do every single one, but try and match them up with your transform sheet. I will include that with the exam when I email out the exam, so you don't have to worry about bringing it. So now we want to do inverse transforms. So the inverse transforms are also linear. So we can take inverse transform of each piece, factor out the 7 and the 4. So this is going to be 7 inverse transform 1 over s cubed. And then plus 4 inverse transform 1 over s squared plus 1. So inverse transform 1 over s cubed, go back to the transform sheet, that's one of the basic transforms. So 1 over s to the n, you do 2 to the n minus 1 divided by n minus 1 factorial. So decrease the exponent on t by 1. So this is an s cubed, so we're going to have that 7. This will be t squared divided by 2 factorial. And then plus 4. Inverse transform 1 over s squared plus 1. So that one looks like this. 1 over s squared plus 1 squared. It's with k equals 1. So that's just going to be 1 over 1 sine of 1t. So just sine of t. And that one's all set. And then here, you should recognize you got a common factor of s, so this is the inverse transform of 1 over s times s minus 5. Okay, and we can't just split apart the multiplication and do the separate transforms. We have to do partial fractions on this one. So your partial fractions, you've got 1 over s times s minus 5 is equal to separate linear factors, so this is going to be a over s plus b over s minus 5. And then remember, you want to multiply through by the LCD. So we multiply left-hand side by s minus 5, and also right-hand side. So on the left-hand side, everything cancels except the 1. On the right-hand side, when you multiply n times a over s, the s's cancel, so you are left with a times s minus 5. When you multiply n times the b over s minus 5, the s minus 5's cancel. You are left with bs. And that's not bs, by the way. I'm serious, it's not bs. And so now we plug in zeros for the denominator. S equals 5. I'm sorry about that. That just, I saw that and I'm like, oh, you should restrain yourself, but I didn't. So you got the bad joke. So let's see here. S equals 5. Left-hand side is 1. This will drop out. 5 minus 5. This will be 5b. So then b is going to be 1/5. And then plug in s equals 0, the other 0 for the denominator. This will be 0 minus 5. So 1 equals negative 5a. And let's see, that's going to mean that, oh, and 0 times b there, that drops out. So that means a is going to be a negative 1/5. So the negative 1/5 is over the s. So that means that we can break this up as inverse transform. The positive 1/5 goes over the s minus 5. So this will be 1/5 over s minus 5 minus 1/5 over s. And then transform's linear, so we can break it apart, take the transform of each piece, and factor out the 1/5. So this will be 1/5 inverse transform 1 over s minus 5 and minus 1/5 inverse transform 1 over s. So we get a 1/5 inverse transform 1 over s minus 5. So that looks like 1 over s minus a here with a equal 5. So e to the at, that's e to the 5t. And minus 1/5. Inverse transform 1 over s is just 1. Okay, so that one's all done. So that was just basic transforms with partial fractions. And then number 8 here, this one doesn't factor in the denominator. This one, what you want to do is complete the square, because you don't have any factors of 20 that add up to -8. Okay, so when it doesn't factor, then you should start thinking shift. So this is inverse transform 1 over s squared minus 8s, and then what we would need to get a perfect square here is we take half of -8 is -4, squared is 16, so -8 divided by 2 squared is 16. So we are going to add that 16 and then subtract it back out. So net is we just added 0 and then plus 20 on the end. So it didn't change the value of that expression. But now we're going to group these guys. And this is going to be inverse transform, and then this will be 1 over. This one factors as s minus 4, s minus 4. So that's a perfect square. So that's s minus 4 squared. And then what's left over, -16 and positive 20, is plus 4. So this is one of the basic transforms, but it's shifted. Okay, so this is actually doing, that's an L inverse there, inverse transform of 1 over s squared plus 4, and then shift that from s to s minus 4. So we're doing inverse of a shift. So inverse of a shift, go to our transform sheet here. We're doing inverse transform of a shift. That's first translation theorem. That introduces an exponential, and then you do the inverse transform of the unshifted function. Okay, so this is transform of little f of t, this guy. So let's see, so this will be an exponential e to the 4t, and then do inverse transform of the unshifted function, 1 over s squared plus 4. And inverse transform 1 over s squared plus 4, that's one of our basic transforms. And that will be this one right here. So you got a 1 on top, and k squared on the bottom was 4. That was s squared plus 4, so k equals 2. So this is going to be 1/2 sine of 2t. Go back to our exam here. So, and we've got an e to the 4t out in front there. So this is going to be 1/2 e to the 4t, and then sine of 2t. And that one's all set. And then up next here we have got Laplace transform, inverse transform, and we've got an exponential with a negative exponent on the inside. So let's go to our transform sheet here, and we are looking for inverse transform with a negative exponential. And that would be this one right here. So that's the second translation theorem. And we are going to get a shifted little f along with a unit step function there. So let's grab this and bring it back over to our problem. So we have to find an f of t minus a, u of t minus a. So let's rewrite this guy first as first transform, e to the minus s and then times 1 over s minus 2 quantity squared. And this is our cap f of s. So from that we're going to find little f, and then we'll translate it. And our translation here, this is e to the minus 1s. So in here, a is going to equal 1. So our a here is going to equal 1. And little f of t is going to be the inverse transform of that 1 over s minus 2 squared. And that's a shifted cap f. That's inverse transform of 1 over s squared. And then that guy is shifted from s to s minus 2. And remember, when you've got a shift here, go back to our transform sheet. We're doing this case here, inverse transform of a shifted f, and it's shifted from s to s minus a, so you get an exponential on the outside, and then the inverse transform of the unshifted function. So this is going to be an e to the 2t, because 2 is the amount of our shift. And then we're doing inverse transform of the unshifted function, 1 over s squared. And that inverse transform is t. So this is actually t e to the 2t. So that's our f of t. Now we want to do f of t minus 1, u of t minus 1. So this is going to be f of t minus 1 times u of t minus 1. And our f of t minus 1 is plug in t minus 1 here and here. So that's t minus 1. And e to the 2 times quantity t minus 1. And then plug that unit step function on the end. And we've got it. And let's see here, we want inverse transform without using partial fractions, inverse transform of this product. So what we want to do there, this is essentially doing inverse transform of 1 over s plus 1 times 1 over s minus 3. So that's inverse transform of a product of two functions of s. So let's go back to our transform sheet. So inverse transform of a product of two functions of s, that looks like this. And that's going to be the convolution of the inverse transforms of these. So do inverse transform of cap f, inverse transform cap g, and then convolution. So it's inverse form of the convolution. So we want to do inverse transform of 1 over s plus 1, and then we're going to do convolution of that with inverse transform 1 over s minus 3, and these are both exponentials. Okay, so this one is e to the negative t, because it's s minus negative 1, and then this is going to be e to the 3t, and we're doing convolution of those guys. And then remember what convolution is. Convolution of two functions. F star g here is this integral, f of tau, g of t minus tau. Let's go ahead and bring that over. Okay, so that's what we want to do. So we are going to do integral from 0 to t. Our f here is e to the minus t, and our g is e to the 3t. So f of tau is going to be e to the minus tau, and then g of t minus tau will be e to the 3 times t minus tau d tau. And this integral is really not too bad. These are all exponentials, so remember when you multiply, you add exponentials. So this is integral from 0 to t e to the minus tau, and then you can multiply that 3 in there, and this will be the same as e to the 3t minus 3 tau d tau, and that is the same as the integral from 0 to t e to the minus tau e to the 3t times e to the minus 3 tau d tau. So if you multiplied these, you would add those two exponents and you get this back again. So I just pulled them apart. So these here we can multiply together and add exponents, and then this is independent of tau, so it can be pulled out of the integral. So e to the 3t goes out in front, and now we're integral from 0 to t. Multiply these guys, you'll get e to the negative 4 tau by adding the exponents, and d tau. And to differentiate an exponential, you'd multiply by the negative 4. To integrate, you're going to divide by it. So we got that e to the 3t out in front, and then the antiderivative here is going to be negative 1/4 e to the negative 4 tau. And that's evaluated from 0 to t. So we got our e to the 3t out in front, and we're going to go ahead and plug in t, plug in 0, and subtract. So this will be negative 1/4 e to the negative 4t minus negative 1/4 e to the 0, so just minus negative 1/4, and that double negative is going to make a positive, and we've got it. So everything is in terms of t. It's, it's not simplified. We could simplify it a little bit more, but it's done. Alright, and so to finish things up, we got a couple of differential equations here. So the first one involves a step function. So one of the first things that we want to do then is to write that step function or that piecewise function in terms of unit step functions. So remember that if you have a piecewise defined function, you can write that in terms of unit step functions with, let's see, where is our formula? It looks like I need to add that one on there. Yep, unit step functions. Okay, so remember that that formula is that your right-hand side function, which is f of t, is g of t minus g of t times u of t minus a and then plus h of t times u of t minus a, where our g is the first function and our h is the second function. So in here for g in both spots we put a negative 1, so this will be negative 1, and then minus negative 1 times u of t minus 4, because here a is 4, that's the change point for the piecewise function, and then plus our h here is 1, so 1 times u of t minus 4. So this double negative is going to make a positive, so we've got 1 plus u of t minus 4 plus another u of t minus 4, I'm sorry, negative 1 plus. So it'll be negative 1 plus 2u of t minus 4. So that's your right-hand side function. That's the first thing we want to do. So now our differential equation becomes y prime plus y is equal to negative 1 plus 2 u of t minus 4. So take Laplace transform of both sides. The transform on the left-hand side You'll take transform term by term. So Laplace transform of y plus Laplace transform, of y prime plus Laplace transform of y is going to equal Laplace transform of -1 and then plus 2 times the Laplace transform of that unit step function, u of t minus 4. So Laplace transform of y prime, that is the first differentiation formula. Okay, here, so for one derivative, this is going to be s y of s, and then minus y of 0. So s cap y of s minus y of 0, and then plus Laplace transform of y is cap y of s. The -1 we factor out in front, and Laplace transform of 1 is 1 over s plus 2, and the transform of the unit step function that is right here, and our f is equal to 1. Okay, so our Laplace transform of 1 is 1 over s. So it's e to the minus as over s. So remember here that if your f of t minus a is equal to 1, then you get e to the minus as over s. That's a special case of this second shift formula. So this is going to be e to the minus 4s over s. And so let's see here, y of 0 is equal to 0, so this term zeroes out. Cap y of s is common factor on the left-hand side. Let's factor that guy out in front. What's left here is an s. What's left here is a plus 1. And on the right side, we've still got our -1 over s, and then plus 2. Let's take our e to the minus 4s out in front. So 2e to the minus 4s times 1 over s. And now let's divide off our y plus 1 on both sides. S plus 1, and then solve for cap y of s. Okay, so on this right-hand side, we will multiply everything by 1 over s plus 1. So these guys cancel. Cap y of s then is going to be -1 over s plus 1 plus 2 e to the negative 4s, and then times 1 over s plus 1. So again, all I did there was multiply in times each term. So then little y of t, our solution then is going to be the inverse transform of that right-hand side. So it's going to be, we can pull the negative sign out in front here. So inverse transform of 1 over s plus 1 plus 2 inverse transform e to the minus 4s times 1 over s plus 1. All right, and then we need to do partial fractions on this. And if you do partial fractions on that, remember it's going to have the form a over s plus b over s plus 1. And if you do the partial fractions, this turns out to be 1, and this one ends up being -1. That's actually a partial fractions that we've done several times before. So I'm going to let you verify that. So this is going to be now negative L inverse, and then here this will be 1 over s minus 1 over s plus 1 and then plus 2 L inverse e to the minus 4s, and times the quantity 1 over s minus 1 over s plus 1. Inverse transform 1 over s is 1, minus inverse transform 1 over s plus 1. That's an exponential. That is one of the basic transforms. So that's 1 over s minus a here. It's s minus negative 1, so it's e to the negative 1t. So e to the negative t. So that's that first part. Plus 2. And then an exponential and s on the inside of an inverse transform. That is right here. So L inverse negative exponential inside cap f of s is a shift times unit step function. So it's an f of t minus a u of t minus a, where a is the exponent on the exponential. So ours is 4. So this is going to be a f of t minus 4 times a u of t minus 4. And then we just need to figure out what is our little f of t. Okay, and this is our cap f of s here. So we do inverse transform of that, and we get this function here. So that means that our little f of t is 1 minus e to the negative t. So we need to plug in t minus 4 there. So then this becomes, oh, I forgot my minus sign there out in front. So this negative we could pull inside and change the signs on both of these. So that would become a positive e to the negative t and a negative 1. And then plus 2, and f of t minus 4, well, this is our f of t, so we plug t minus 4 in there. So this will be times 1 minus e to the negative of t minus 4. And then that whole thing gets multiplied by u of t minus 4. And there's our solution. Alright, and one more differential equation here. So we want to use Laplace transforms to solve y double prime minus 4y prime is 2 plus delta of t minus 3, subject to y of 0 is 0, y prime of 0 is 1. So take transforms on both sides. So Laplace transform of y double prime minus 4 times Laplace transform of y prime is going to equal, on the right hand side, Laplace transform of 2 plus Laplace transform of delta of t minus 3. So transform of y double prime, that's s squared cap y of s minus s y of 0 minus y prime of 0. That's the first differentiation formula. And then minus 4 Laplace of y prime is s cap y of s minus y of 0 equals transform of 2, well, the 2 can come out in front, and transform of 1 is 1 over s, so this will be 2 times 1 over s, 2 over s, plus, and now transform of delta of t minus 3, so that's way down here at the end. So transform of delta of t minus t0, e to the negative s t0. So our t0 is 3, that's going to be e to the negative 3s. So e to the negative 3s. And let's see, y of 0 is 0, so this term drops out, 0. Y prime of 0 is 1, so that's a 1. And y of 0 here is 0. So we've got an s squared cap y of s and minus 4s y of s. And then we've got a minus 1. Let's bring that over on the right as a positive. So this will be 1 plus 2 over s plus e to the negative 3s. And now y of s is common factor. Factor that guy out in front. What's left is s squared minus 4s equals 1 plus 2 over s plus e to the negative 3s. And divide both sides by s squared minus 4s. So divide everything on the right by s squared minus 4s. And these guys cancel, and so now we've got our y of s. And then notice there's a common s in there, so that factors, that's actually s times s minus 4, which is going to need partial fractions. And then same thing here, we can factor out that s, and we'll have an s squared on the outside times s minus 4. And that's going to need a partial fractions. And then plus, pull the e to the negative 3s out in front, times 1 over s minus 4. So the partial fractions for 1 over s minus 4, that's not too bad. So if we pull that guy off to the side, 1 over s minus 4 is equal to a over s plus b over s minus 4, multiply through by s minus 4, the LCD, and you get 1 equals a times s minus 4 plus bs. And plug in s equals 0, and you get 1 equals negative 4a. This term drops out. So a is negative 1/4, and plug in s equals 4, and you get 1 equals, this term drops out, 4b, so b is positive 1/4. So it'll be 1/4 over s minus 4, negative 1/4 over s. So we can break this up now and say this is going to be 1/4 over s minus 4 minus 1/4 over s. And then this also needs a partial fractions. So if we do that one, it's going to be a little bit different. So that one is going to be, so 1 over s squared s minus 4 is going to have an a over s and a b over s squared and a c over s minus 4. And so multiply through by LCD, and we're going to get 1 equals s minus 4 plus b times s minus 4 plus c times s squared. Plug in s equals 0. We get 1 equals, this term drops out, this will be a negative 4, so negative 4b, and then this term drops out. So b is negative 1/4. S equals 4. Gives 1 on the left-hand side. On the right-hand side, this term drops out. This term drops out. So let's see, 16c. So that means c is 1/16. Oh, you know what? We've got a 2 actually in the numerator there. That's just going to make 2's on the left-hand side here instead of 1's. And it's going to double our constants. So this will be a 2, 2, 2, 2. So this will actually be a negative 1/2. That'll be a positive 1/8. Sorry about that. So negative 1/2, positive 1/8. And then for the last number, you can plug in anything you want. So we could plug in like s equals 1. So if we plug in 1, we get 1 times 1 minus 4, negative 3a. So 2 equals negative 3a. And a 1 in here, negative 3b, and b is negative 1/2. So negative 3 times negative 1/2, positive 3/2. And then a 1 in here gives plus c, so plus 1/8. And so let's see, if we take this stuff and bring it over on the left-hand side, subtract it, well, we get 3/8 on the left-hand side equals negative 3a. And then that tells us then that a, dividing both sides by negative 3, is negative 1/8. So this is going to be plus, okay, so our a is negative 1/8, negative 1/8 over s. B is negative 1/2, so minus 1/2 over s squared. And then c is positive 1/8 plus 1/8 over s minus 4. And then e to the minus 3s. And then this one is the same as this one. So that's going to break down as 1/4 over s minus 4 minus 1/4 over s. So then little y of t, to line things up, is going to be inverse transform of this guy. Let's clean this out of here. Give ourselves some room to breathe. So let's see, so inverse transform here, 1/4 will come out in front. Inverse transform 1 over s minus 4 is going to be e to the 4t minus, pull this 1/4 out. Inverse transform 1 over s is just 1. And then minus 1/8, pull that out in front. Inverse transform 1 over s is 1 minus the 1/2. Oh, that should be an s squared. Inverse transform 1 over s squared is t plus 1/8. And inverse transform 1 over s minus 4 e to the 4t. And then inverse transform an exponential in s times a function of s. So again, that is this formula here. So e to the negative as f of s, you do a shift times a unit step function where that a is the coefficient of s. So this one is going to be, let me write it underneath, f of t minus, our a is 3 here. So f of t minus 3 u of t minus 3. And this is our cap f of s. So cap f of s is equal to 1/4 over s minus 4 minus 1/4 over s. So then that tells us that little f of t is, well, we already did that. We did that right here. That's this inverse transform. That's 1/4 e to the 4t minus 1/4. So that's our f of t. We want to do f plug in t minus 3. So this is going to be 1/4 e to the 4 times t minus 3 minus 1/4, and that whole thing times u of t minus 3. And we got it. And there is a little bit of simplifying we can do. We've got some like terms here. Let's see, we've got some like terms here that we could combine. So there's a little bit of simplifying, but we've solved the differential equation. And you don't have to simplify on test. So this one's done. And then to wind things up, we just want to remember what's the importance of unit step function and what physical situations does it help model. So your unit step function, the importance there is you can rewrite any piecewise in terms of that unit step function u of t minus a. And we know how to take Laplace transforms of that easily. So it lets us take transforms of any piecewise function. And the physical situations that it helps model, that's your on-off switch. Like for an electrical circuit, turns a function off and then on. And then for Dirac delta, what's its importance and what physical situations? So the importance here of Dirac is it models impulse functions. Actually, unit impulse functions. And those are high magnitude, short duration. And then physical situations, one example here for physical situations, an example would be a bat. Easiest one is a bat hitting a ball. So you got a very high magnitude, short duration force that hits that ball and drives it for the home run. Okay, so the actual exam will be similar to this. It's going to be a variety of forward transforms, a variety of inverse transforms, two equations, two full equations, and they may not, they won't be identical to these, but similar. I'm going to have you do something with unit step functions. I'm going to have you do something probably with Dirac delta, because those are the two special ones that we've done. And all the other stuff in here, it's probably not going to be as heavy as this one was with, the two partial fractions in there. But if you had one partial fraction like this, I think that's reasonable. And it will be shorter than this practice exam. So I'm going to pick and choose, and you do get your transform sheet, and I will put the piecewise function formula on there for you. All right, very good. That's a